Assalamu alaikum. My name is Manjwed, roll number 191063. Today in this video I will cover lab number 10 of Dld Lab course. So this is our lab number 10, in which we have to verify that universal gates can be used to implement different functions like decoders, encoders, multiplexers and demultiplexers. So there are some circuits we need on Proteus. First of all, I am going to open the 2x4 decoder. So this is our 2x4 decoder, and here it is the truth table of 2x4 decoder. So we verify the truth table by running the simulation. So at 0 0 our output is 1 at out 1 and 0 at the remaining ones. So when we give it input of 0 at A and 1 at B, so we get 1 output at out 2. When we give it input of 1 at A and 0 at B, we get the output of 1 at out 3, and at last we give it input of 1 1 at both A and B, so we get the output of 1 at out 4 and 0 at remaining ones. So now we open the circuit of 4x2 encoder. So here is the circuit of 4x2 encoder. So when we give it the input of 1 at A and 0 at the remaining ones, we got the output of 0 at both out 1 and out 2. So when we give it 1 at B and 0 at remaining ones, we get the output of 0 at out 1 and 1 at out 2. When we give it the input of 1 at C and 0 at remaining ones, so we get the output of 1 at out 1 and 0 at out 2. And at last we give it the input of 1 at T and 0 at remaining ones. So the output that we get after giving it input of 1 at T is 1 at both out 1 and output 2. So this is so we verify the truth table of 4x2 encoder. Now we are going to open our 1x4 Demux. So this is the circuit of our Demux. So we give it this is the truth table of Demux. So we give it inputs, we give it input as on the truth tables. So first we give it the input of 0 at both S1 and S2. So we get output of 1 at output 1. When we give the input of 1 at S2, we got the output of 1 at output 2. When we give it the input of 1 at S1 and 0 at S2, we got the output of 1 at output 3. And similarly, when we give output of 1 1 at both S1 and S2, we got the output of 1 at output 4. So this is the circuit of Demux, and we verify the truth table of Demux. So now we come on to the mux. This is the circuit of mux. So we give it inputs according to the truth table. So we give it the input of 1 at A and 0 at the remaining ones. So the output we get is a 1 at A, and now we give it input of 1 at B and 1 at F. So we got the output of 1 at B. Now we give input of 1 at C and 1 input at S1. So we got the output of 1 at C. So when we give it input of 1 to D and 1 to both S1 and S2, we got the output of 1 at both 1 at D. So we verify the truth table of mux. So now we come on to the shortest part of these circuits.
In Encoder, first of all, we write the Verilog code of decoder. This is our Verilog code. Now we run the simulation of the code. The simulation is running successfully, and this is our output of decoder. Now we write the Verilog code for encoder and observe the simulation of encoder. Now we run the simulation, and the simulation is working successfully, and here is the output of our encoder. Now we write the Verilog code for Demux and observe the simulation of Demux in our quarters 15. Now here we run the simulation of our Demux Verilog code after giving inputs, and here is our output. You can see on the screen. So that's all from the Demux. Now we are going to write the Verilog code for Mux in our quarters 15. We save the file by the name of Mux Lab 10, and now we are going to write the Verilog code on our quarters variant 15. We select Verilog ATL file from the options, and here is the code of Mux for our lab number 10. We compile the code. Now it takes some time to compile completely. Now we assign the values to the inputs, and after it we run the simulation to get the output of these inputs. So we run the simulation and simulation is successful, and here is our output of mux. That's all over from lab number 10. Hope you like the video. Allah Hafiz.